Some exercises on circular motion and maybe some, pinches of simple harmonic motion, but majorly circular motion. Calculations on circular motion. Question 1 here says, a stone is tied to a string. A stone tied to a string made to revolve. A stone tied to a string is made to revolve in a horizontal circle of radius 4 centimeters with an angular speed of 2 radians per second. With what tangential velocity will the stone move off the circle if the string cuts? That's a simple question. We know the angular velocity 2 radians per second, and we know the radius of the circular part. So we are looking for the tangential velocity. The relationship between V and RW. The relationship between V, R, and W is V is equal to RW. So that means V is RW will be used, and we get 4 times 2, which gives us 8 meters per second. Question 2 says, so V is the linear velocity, R is the radius of the circular part, and W is the angular speed or angular velocity. So question 2 says, a body weighing 100 newtons moves with a speed of 5 meters per second in the horizontal circular path of radius 5 centimeters. The question says, calculate the magnitude of the centripetal force acting on the body. Calculate the magnitude of the centripetal force acting on the body. This is a very simple question too. F is equal to ma. That's what we are going to use here. F is equal to ma. So that means centripetal force is mass of the object times centripetal acceleration. So we have the weight of the object, 100 newtons. So we can easily get the mass of the object. Weight is mass times acceleration due to gravity. So that means W is mg. So if you do that, you get 100 is mass times what? 10. So since acceleration due to gravity is given as 10 in this question, so 10m is 100. M is 100 over 10. The mass of the object or body is 10 kilograms. In this question, we have the velocity. We have the linear velocity around the circle. We also have the radius of the circular part. So in this question, centripetal force will be ma, and A is v squared over r. Centripetal acceleration is v squared over r. So that means ma will be mv squared over r. That gives us 10 times 5 squared all over what? All over 5, to give 50 newtons. So take note of that too. Next question in 3 says, in question 3, an object of mass 5 kg moves round a circle of radius 6 meters. It says, if the period, let me turn up this light a bit. It says, if the period of motion is pi seconds, calculate the force towards the center. The force towards the center is the centripetal force. So this is a simple question. Mass of the object is what? 5 kilograms. Radius of the circular part, 6 meters. Time, pi seconds. So the centripetal force using F is mv squared over r. The centripetal force will be mass times what? V squared over radius of the circular part. Now, to get the radius of the circular part, to get the linear velocity around the circle, we do V is RW. So V is RW. W is 2 pi F. And that's what? 2 pi times frequency. Frequency is the same thing as 1 over period. We did that in the first video on circular motion. So 2 pi times 1 over pi. 2 pi times 1 over pi. Since our period is what? Pi second. 2 pi times 1 over pi will give you 2 radians per second. So V is RW. V will be 6 times 2, which gives what? 12 meters per second. So your linear velocity around the circle is what? 12 meters per second. So centripetal force will be mass 5 times 12 squared over what? R. mv squared divided by R. That gives us 120 newtons as the centripetal force. In question 4, a particle of mass 10 raised to the power minus 2 kg is fixed to the tip of a fan blade which rotates with an angular velocity of 100 radians per second. The question says if the radius of the blade is 0.2 meters, the centripetal force is. So in this case too, it's a simple question. We know the mass of the, we know the mass of the object. We know the angular velocity with which the fan blade is rotating, and we know the radius of the fan blade. Centripetal force will be what? Question mark. That's what we are looking for. So first thing, let's get our linear velocity around this circle. V is RW, as in radius of the circle times angular velocity. So V is what? 0.2 times 100. That gives 20 meters per second. If you get 20 meters per second as V, all you have to do is what? All you have to do is what? Go to your formula for force, mv squared over r, and do mass times v squared. We've gotten v as 20, as you can see here. So v squared will be what? 20 squared. That's mass times 20 squared over radius of the circle, which is 0.2. That gives us, the mass is the same thing as what? The mass is the same as 0.01. 10 raised to the power minus 2 is the same thing as 10 raised to the power minus 2 is the same as 1 over 100, which is 0.01. So that gives 0.01 times 400 over radius, which is 0.2. That's 4 over 0.2, that's 20 newtons. So the centripetal force is what? 20 newtons. Now, in the next question, question 5 says, a body moves along a circular path with uniform angular speed. Moves with uniform angular speed of what? With uniform angular speed of 0.6 radians per second and at a constant speed of 3 meters per second. The speed is v, 3 meters per second. The angular speed is 0.6 radians per second. So looking for v, v will be rw. That's what v is equal to rw. So our radius is v over w. Radius is 3 over 0.6, which is 5 meters. Take note of this. Now, for your centripetal acceleration, A is v squared over r. That's what? That's 3 squared over what? 5. So that's 9 over 5, which gives 1.8 meters per second squared. So your centripetal acceleration is 1.8 meters per second squared. Take note of that. Now, in question 6, it says a body executing a simple harmonic motion. A body executing a simple harmonic motion has an angular velocity of 40 radians per second. Has an angular velocity of 40 radians per second. As you can see here, W is 40 radians per second. Has an angular velocity of 40 radians per second. It says if it has a maximum displacement of 6 centimeters, calculate its linear speed. That's a simple question. Now, maximum displacement in simple harmonic motion is referred to as the radius of the displacement, which is 6 centimeters. Now, 6 centimeters is the same thing as 6 over 100. 6 over 100 is 0.06 meters. So to find the linear velocity, you do v is rw. So that V is AW, which is 0.06 times what? 40 radians per second. That gives you what? That gives you 2.4 meters per second. That's question 6. Done. Question 7 says the angular speed of an object describing a circle of radius 4 meters with a linear constant speed of 10 meters per second is 10 meters per second. With a linear speed, sorry, let me read the question again. The angular speed of an object describing a circle of radius 4 meters with a linear constant speed of 10 meters per second is, so we want W. In this question, we want W, which is the angular speed. Let me try and draw a small diagram that we, kind of depict the picture of everything we've been saying. If I have a circular path like this, so if I have a circular path like this, what you have here is the radius of the circular path. Let me try and write that word. That's the radius. Now, at any point in time, a tangent to the circle gives the linear velocity. The linear velocity at this point is a tangent to the circle at that point. Then, angular velocity is what? W. So in this question, we are asked to find angular velocity in question 7 when the linear velocity is 10 meters per second, the radius of the circular path is 4 meters, and we don't know the angular speed. So using V is RW. The relationship between the linear speed, the angular speed, and the radius of the circle is V is equal to RW. So 10 is equal to 4 times what? W. Since the radius is 4 and the linear velocity is 10. So 4W is 10. If you rearrange or swap sides, W will be 10 over 4, which gives what? 2.5 meters per second. That's a very simple question if you look at it very well. Question 8 says, let's go to question 8. Okay, here. Question 8 says, okay, let me try and make it bigger. Question 8 says, a body executing a simple harmonic motion has an angular velocity of 22 radians per second. Okay, angular velocity 22 radians per second. That's W here. Then please leave space between your solution. It's very important. This was a note I wrote. Maybe in a quick fashion, I didn't notice the space wasn't enough. So angular speed is 22 radians per second. The question says, if it has a maximum displacement of 10 centimeters, take note that centimeters is not the SI unit of length. So if it has a maximum displacement of 10 centimeters, that means A is R, and the radius of the displacement or the radius of the motion is 10 centimeters. 10 centimeters is not the SI unit. Centimeter is not the SI unit of length, so you change it to meters by dividing by 100. That will give you 0.1 meters. So, the question says, what is its linear velocity? Linear velocity V is RW. So, V will be 0.1 times 22. That gives 2.2 meters per what? Per second. Take note of that too. Let's go to question 9. Question 9 says, a particle in circular motion performs 30 oscillations in 6 seconds. So number of oscillations or complete revolutions is 30. Time taken to perform those revolutions is 6 seconds. The frequency of the object or frequency of the motion of the particle is what? Number of revolutions over time taken. So that gives us number of revolutions over what? Number of revolutions over time taken. That gives us 30 revolutions divided by 6 seconds. So the frequency of oscillation will be 5 revolutions per second, which is the same thing as 5 hertz. Now, 5 hertz, we are looking for W. The question says we should find W. The question says its angular velocity is W. Let me jot it down. Angular velocity, W. So W is what? 2 pi F. That's 2 pi times 5, 10 pi radians per second. Now, question 10, that was question 9. Let's go to question 10. Question 10 says, the amplitude of a particle executing simple harmonic motion is 5 centimeters, while its angular frequency is 10 radians per second. In this case, the angular frequency stands for the angular velocity. So interchangeably, sometimes it's called angular frequency. Calculate the magnitude of the maximum acceleration of the particle. That's a simple question. Write down the radius of the oscillation, which is 5 centimeters. 5 over 100 will give you 0.05 meters. So W is 10 radians. Maximum acceleration, very simple. So we go to A is V squared over R. The maximum acceleration of that object in simple harmonic motion is V squared over R. Now V is RW. That means V squared over R will be RW times RW, or RW all squared, divided by what? R. That's R squared W squared over R. That will give us RW squared. You know, R will divide R. You have 1 R left, and W squared. So take note of that. Now, if the maximum acceleration is RW squared, that means our acceleration will be 0.05 times what? 10 squared times what? 0.05 times 10 squared, which is RW squared. So that gives us 0.05 times 100, which is 5 meters per second squared. Let me give you 1 or 2 questions to answer as your classwork. So please jot this down. Classwork, question 1. I'm just going to give you similar questions like, the ones we've treated. Question 1. Are you ready? A stone tied to a string is made to revolve in a horizontal circle of radius 7 centimeters with an angular speed of 4 radians per second. With what tangential velocity will the stone move off if the circle? With what tangential velocity will the stone move off the circle if the string cuts? That's question 1. Question 2. A body weighing 50 newtons moves with a speed of 10 meters per second in a horizontal circular path of radius 6 meters. Calculate the magnitude of the centripetal force acting on the body. G is 10 meters per second squared. Take G as 10 meters per second squared. That's the value of acceleration due to gravity. Question 3 now. An object of mass 10 kg moves around a circle of radius 14 meters. If the period of motion is 3 pi seconds, calculate the magnitude of the centripetal force acting on the body. Or calculate the force towards the center. It's the same thing. The centripetal force acting on a body moving in circular motion acts towards the center of the circular path. Let me just give you 5 questions. So question 4 now. Question 4 says, a particle of mass 10 raised to the power minus 3 kg is fixed to the tip of a fan blade. Which rotates with angular velocity 200 radians per second. If the radius of the blade is 0.4 meters, find the centripetal force. Question 5 now. A body moves along a circular path with uniform angular speed of 2.4 radians per second. Question 5. A body moves along a circular path with uniform angular speed of 2.4 radians per second and at a constant speed, that's the constant linear speed v, and at a constant speed of 9 meters per second. Full stop. Calculate the acceleration of the body. Calculate the acceleration of the body towards the center of the circle. So what we mean here is that you should calculate the centripetal acceleration. Every question is similar to the example, just a change of values. So best of luck. You submit that before we start the next class